Hello and welcome back to Element 14. I'm Liz and today we will be building a catapult alarm clock. It doesn't actually catapult you out of your bed, but there is a catapult and an alarm clock. Sometimes conventional alarm clocks just don't cut it. You put your phone across the room only to wake up an hour after it was supposed to go off with no recollection as to how it ended up underneath the mattress at the foot of your bed. That did actually happen to me once before. So I decided to make an Arduino alarm clock that will wake the dead and hopefully keep the dead awake long enough to not go back to sleep. Something that'll force me to get up, maybe use some fine motor skills. So I came up with a little plan for that. Let's go do this. Most Arduino clocks have some pretty standard components like an LCD to display the time and the alarm, an RTC to keep track of the time, and a buzzer to actually wake you up. A lot of them also have buttons for you to interact with the screen and the clock and such. I have the attention span of a gnat, and I don't really like the buttons, partially because you have to press them a bunch of times to get one number, but also I wanted to implement some kind of fine motor task, like having to type something on a screen, and that would be a pain with buttons. Also, it wouldn't really force me to get out of my bed and move around. The idea I had was to use an infrared remote. That way, I would have lots of free pins and lots of buttons that I could press. Additionally, I could put it somewhere across the room, then I'd have to get up and find it. And what better way to put a remote somewhere in your room than to use a catapult? I mean, what could possibly go wrong catapulting a remote control across your bedroom? That's catapults just make everything better. So this is what I'm gonna do. I'm gonna build a catapult to launch this remote across my room, and then I'm gonna have to get up, I'm gonna have to find it, searching, gross motor skills, and then I'm gonna have to retrieve it, type in this code. I can use a servo or something like that to trigger the catapult. This is the plan that I have right now, so I'm going to attempt to build this, and we'll see what happens. Here's a schematic of the circuit that I came up with. There's a lot of stuff, so I'm gonna just go over everything really quick. I've also included links on all these different components to look at closer and how they work individually. So first we have this DC motor up here, and I really wanted to use a servo to set the catapult off, but because of a bunch of other things and the way the code worked, it didn't end up working out, so I had to use a DC motor instead, and to connect it you have to use a transistor and a diode. As such, it ends up being connected to pin 2. Then there's the buzzer to wake you up when the alarm goes off, and it's also connected to a transistor to make it even louder and more wonderful to wake up to. Then there's the RTC, the clock, which keeps track of the time, and it uses IC2, so it's going to be connected to pins A4 and A5 on the Uno. It'll be slightly different on different Arduinos if you want to look it up. Then there's the LCD, which you have data buses 4 through 8. I'm not going to use all 8, too many pins. And that's wired pretty standard. You have E to 8, and RS is going to go to 9, read write to ground. Then there's the IR receiver, which is going to receive the codes from the remote so we can interact with the clock right here. And that is everything. It's a lot, but that's everything. We're going to test the alarm circuit out now and see if it works. Wow, okay, that definitely works. That definitely works. Okay. I'm not actually going to include the buzzer in this test. I pulled the pin out because it's horrible. It's excellent for waking the dead, but it's horrible for talking over. So in order to hear myself think, I've replaced it with this little LED here, which I'm going to leave in for troubleshooting purposes, but that's going to be the indicator for the buzzer for now. It will come back in the final test, so don't worry. We'll have the buzzer, and the catapult will also be there for the final demo. The clock has 3 states, so to speak. There's showing the time, showing the alarm time and letting you set it, and then when it goes off and it starts beeping, the catapult goes off, it's going to make a code that you're going to have to type in on your remote. So I'm going to bring up the code and we'll take a look at how this functions. Looking at the code, it's pretty long, so I'm going to spend some time on it. There's a number of libraries for the different things used. I've included links to all of those. Some of them are pretty standard, like the LCD, and then you have ones here like Newtone, which everything really wants to run on the same timer, and that was causing a lot of issues. I couldn't get the buzzer to run, so I had to download this other library because I don't actually know how to put things on different timers. The biggest issue I ran into was trying to get the servos to work, which didn't actually end up happening. I downloaded a special library and it still it kept running on the same timer as the IR remote. And again, I believe there's a way to change this, but since I am not familiar with it, I instead replaced the servo with a DC motor, and I went through a lot of trouble to get this thing to work. As you can tell, there's a lot of finagling, and you'll get to see, we'll see more of that with the catapult, but I'm a little disappointed that that didn't work. If you find a way to get it to work, feel free to use a servo, and it will probably make your life a lot easier. If I mention servo, I'm actually talking about the motor because, again, I was originally planning to use a servo. So for the purposes of going over the code, I'm sort of using those interchangeably. But in the end, I did end up going with the motor. But some of this I did before I decided that. So I did, just to clear up any confusion that might occur. You may notice that the pins are a little bit different than the ones that I showed in the schematic, and they both work. I just ended up changing things around a little bit. As long as they're consistent with the pin layout, they both should work. There are a lot of variables. Some of them, these ones here, correspond to the hour and minute values for the alarm clock. Other ones down here are placeholder values because the infrared remote was doing this weird thing where whenever I tried to save a variable, it wouldn't do it whenever I reset the remote. So to get around this, I essentially had to use 2 variables for every one variable. You can see an example here. I tried to save y to itself plus 1, and that didn't work, so we have to save y to yy, and then after you've reset the remote, you save yy to y, and you essentially have to do that for every loop where you reset it here. I'm not exactly sure why, but that was a thing that was causing a lot of problems. I made some functions here for things that happen repeatedly. Hopefully the names are fairly self-explanatory, and they're all written down here. There's a little section for them. The different states correspond to their own loops, so this is the time loop. It shows the time, and if you press this the button, the CH minus button, the code will switch the T value, and that will put it into the alarm loop, so the T values determine
which loop you're going to be in. In the alarm loop, you can go back to the time loop, or you can input a value to change, to set the alarm. You can input any number that you want, and you can also use the plus and minus keys to change which digit your cursor is on. This is the loop where the alarm goes off when the time equals the values that you've set for the alarm. That's when all hell will break loose, and this thing will start blaring, and the catapult will release. It'll be a good time. If you want to just test the alarm function and make changes, you can have them set equal to each other automatically and play around with it. Once the alarm goes off, it's going to make an array that's going to appear on the screen, and you'll have to type in the corresponding digits. I only had this array 4 digits long, using 0 through 2, because I don't even think I'm going to have enough brain power to figure that out with this thing blaring at me. If you want something harder, you can make the array longer. You can add more values than just 1 through 2. Just make sure that in the make array function, that's where it determines what numbers it's going to display. And it would be really bad if it showed a number that you couldn't type on the remote, because then the alarm would just never turn off. But if you want to play with that, you can go in and make some alterations. For every value in the array, you are going to have to type a number in, and then that's going to be saved to its own array 2, and if they match, you get to move on. Yay, next number. Otherwise, if they don't match, you get set back to 0, and you have to start typing everything in all over. Once you've typed in everything correctly, assuming you have, everything will turn off, and you will be free from the horrible beeping. It will go back into the time state, and for the rest of the minute, it'll just say alarm off, because otherwise it would go back into the loop. And that is essentially all of the code. If you have questions about specifics or some of the functions or anything I didn't mention, or suggestions for improvements, because I'm sure there are many opportunities for that, just leave a note in the comments. One last thing to note is that the angle at which you put the servo for the catapult and the angle to release is going to depend slightly on the specifics of how you build your catapult. So now let's go look at how we're going to go do that. Let's build the catapult.
So here's the catapult. It doesn't have the motor up here yet, but I'm going to go over a little bit of how I made this. It's made out of pretty common stuff, popsicle sticks, and these in here are actually old gift cards that I then fortified with a CD case. I included a little diagram with some dimensions. The exact dimensions are not super important as long as the remote fits in and everything fits together. It's really meant to be more of a guideline so that you can then scavenge around your own home and find weird things to make this out of. So originally I started with some old gift cards that I taped together, and in the back you have some screws that hold it, and a cutout popsicle stick to make this little square shape that you insert the remote into. And that didn't end up being super sturdy, so I took some CD cases and I cut those in half, put them together, and then glued them with hot glue along the top and the bottom to make this nice square shape that you can insert the remote into. On the end here, you have these popsicle sticks glued, sticking out, and you put the rubber bands on them so that you can shoot the catapult. So the trigger mechanism is in here, but you can take it out. It's just 2 popsicle sticks glued together with some string going through it. I actually drilled a little hole for it in here. And this bit is the back of a mechanical pencil that is there so that it doesn't move around too much while it's in this little space, and it stays nice and steady as you are shooting. You just wrap the rubber bands around the 2 popsicle stick ends like this so you can remove it pretty easily. You want to make sure both the rubber bands are the same tension, but you can figure out what level of tension works best for your specific device. In the back, I didn't want to have it be super long and just pull straight back, so I made this little pulley here. It's made out of just bottle caps that I glued together and then glued like this, so the string wraps around and then it hooks onto the top part, this little thing sticking up right here, and then the motor is going to flip that off, and that's going to shoot your remote control out. So you take your remote and you take your catapult, put the remote into the catapult, pull the trigger back and hook it on your little hook up here, and then to test it out, we'll just ooh, there it goes. Don't aim this at people's faces. Don't aim it at breakable objects. Be careful, I guess, if you have a lot of breakable things in your room, because that's not a thing anyone needs in the morning. Here is the little motor thing that I made. I was really set on using a servo, and so when that didn't work, I was very disappointed. I even glued the servo in up here and then had to take it all out, but because it doesn't stay fixed the way a servo would, I had to make some modifications. This thing is a little bit Rube Goldberg overkill. It's also because the motor I had isn't very strong. If I had a stronger motor, I would definitely maybe get rid of some of this gear work, or if I had a gearbox, that would make this easier. But this goes right here, and it flips the string off when it's pulled. So here's everything put together. I'm actually going to try and take a nap right now, and I'm going to turn this on, and we will see if it wakes me up, because if it doesn't, then probably nothing ever will. Oh no. This is very loud. Whew. Okay, it's over now. So today we built an Arduino alarm clock with a catapult that shoots an infrared remote across the room that, once retrieved, is used to put in a code and turn the alarm clock off. Given more time, I would want to solder everything together and take it off of the breadboard. I'd want to get a better DC motor with a gearbox, or maybe find another way that I could get the servo to work. As much as I complain about the beeping, I could have changed that really any time. So I'd maybe play around with more sounds to wake up to, although I guess the beeping is pretty effective. That's all we have for today. Have you ever built a clock that tries to do a lot of other things, or had an Arduino project where you tried to run a bunch of things on different timers, and how did that work out? Let us know on the Element 14 community at Element 14 Presents, and we'll see you next time. Time, because it's a clock. Never mind.